Okay, I think we're good. All right, any questions over the homework? I see a hand up, but I won't be able to hear. Go ahead and take out your homework if you haven't figured that out. I see like most desks with homework. But yes, Luca. 45. 45, he says. All right, here we go. I'm trying to remember. Did the instructions give us a hint of U substitution? If not, okay, so I'll walk through this. So, I mean, first of all, remember the separation of variables thing. So there's no y. There's no y over here. So I just moved the dy over, or kept the dy on that side and just moved the dx over, but then integrate both sides. So just any questions getting to this point? But then the question is, how do we integrate this? And like this would be my thought process. It's a pretty short thought process. I'd look at this and go, there's two things with an x. Like I won't be able to just take the antiderivative of a square root because I have this x hanging out here. But I do notice a composition. I notice an x minus 3 inside a square root. Now, the derivative of the inside would just be a 1. And I don't just have a 1 out here. So I'm off by more than just a constant. So I don't know that U substitution is going to work. But it still could. And so I try it. You let U equal the inside function. And I just went with it. So that means the inside turns to U. Du is just dx if this is my substitution. So dx turns to du. I still have an x, though. So that's why I took this equation and solved for x. And got this, and then I noticed, now I have something I can just distribute, and that'll be easy to do power rule. So that's the thought process with it. Any questions on that? Any other questions? Welcome back, by the way, Boom! Let's just like slam math in your face, When's the last time you guys did any calculus? I'm guessing it was either last night because you were rushing to do your homework, or you did your homework like at the beginning of the week and it's been days. How many people just did their homework last night? It's okay. I'm not no judging. I mean, who hasn't graded your tests yet? So, anybody do their homework like at the beginning of the week? And then it's been a while since you've thought about calculus, Oh, don't worry. No reality check today for this very reason. Any other questions? Then let me have your homework, please. Pass up your homework.
But I went to the back. No way. It was the grass.
Thank you. All right, so there is no reality check. Go ahead and take out your notes. We're going to jump right into notes.
Yes.
Oh, by the way, it's not going to be until the last problem, but let's just go ahead and do it now. Go ahead, take out your calculator if you got it. If you don't have it, go ahead and grab one from the side. I'm going to show you some more stuff on the calculator today. This is not the last unit. It's close to the last unit. It may be the last unit. We'll see. How you doing? Would rather be in bed? I understand that. Okay. Today's focus is all about finding the area between two curves. We already know how to find the area between the x-axis and a curve, but what about between two curves? And so let's find out. We could have actually 3 different scenarios, though. Those two curves could be both above the x-axis. You could have one above and one below the x-axis, or they both could be below the x-axis. So let's look at all 3 of those cases and see how we handle them. So let's look at case 1. Both curves are above the x-axis. Dun, dun, dun. So let's draw a little picture here. So let's say that curve 1 is just here. I'm going to call this y equals f of x. And I'm going to put, oh, I don't want that thick one. There we go. And then y equals g of x will be this guy down here. And then let's just say that I want to find the area between these, but also between the vertical lines, x equals a and x equals b. So I'm looking at this area right there. So we can see very easily all we need to do to find this area, the yellow areas. Let's find the area between the x-axis and f, and then we'll subtract off the area between the x-axis and g. So let's write this out. So the area is the area between the x-axis, Godzilla, and f of x minus the area between the x-axis and g of x. And now let's change this into math. How do I represent, using math, the area between the x-axis and f? Go, Jay? Sorry, say it again. So can you give it to me, what the integral looks?
F of x dx minus integral b to a dx.
Yes. Now the only thing, I don't know which way you meant it. We do want to put the a on the bottom.
Yeah,
And so we read it from a to b.
oh.
You got it, though. Yes. And they have the same limits, the two integrals, so we can actually just combine this into one integral and say that the area is the integral from a to b of just f of x minus g of x. Ta-da! So when both curves are above the x-axis, if you look at the relationship between f and g on the graph, f is the top curve. So we can just think of it as top minus bottom. It's the integral of top minus bottom. And here I'll just put on all of this. Top, bottom. So that's what happens when they're both above the x-axis. So any questions what I was doing there, how I got it? So now let's see what happens when we have one of each. One curve is above and one curve is below. I'll give you a second there. Anybody still need this before I scroll? Okay. The next thing is going to be one curve above the x-axis and one curve below the x-axis. So we'll draw a picture to represent that. Blah, blah, blah. Is my laptop in your way? Okay. Anybody still need the old stuff? Ready. So we'll set up another graph here. I'll put y equals f of x above the x-axis, y equals g of x below the x-axis. We'll put our two vertical lines, x equals a, x equals b, and we're looking at this area. So now it gets a little weirder because we're below the x-axis for part of it. So this time, rather than subtracting, we're going to add. We're going to take the area between f and the x-axis and add the area between g and the x-axis. And that'll put both of these together. So let's write that out. So the area is the area between x-axis and f of x plus the area between the x-axis and g of x. So any questions what I'm doing here? So now we're just going to translate this into math. So how do I represent the area between the x-axis and f of x using an integral? Andrew?
Okay, so, would that be like, integral?
Uh-huh.
Integral a and b, f of x dx, plus integral, b, a.
Actually, I'm going to put, oh,
Do
you want b on the bottom?
No.
Oh, okay.
Like that. G of x. G.
All right, what do we think? We got it? Marcus? Yeah.
All right.
Yeah, so we have the area between the x-axis and g, since that's below the x-axis. Remember, the value of the integral would be negative. But we want this area to be positive. We're not talking signed area, we're just talking area. So we could do the absolute value, but I can also, Yoj? Yeah, because I'll just negate the integral. If we negate the integral, then it will negate a negative and turn the area positive. And then that does have the effect that Yoj was talking about. So very good, you guys. So it's going to be the integral of f of x dx from a to b minus the integral of g of x dx from a to b. And we still have the same limits of integration, so I can combine this into one integral and just say that the area is the integral from a to b of f of x minus g of x dx. So any questions how I got there? So then this time, looking at the relationship between f and g, f is the top and g is the bottom. Oh wait, what we got above. Oh, that's good. It's still just top minus bottom. So luckily we don't have two different things to remember there. Any questions about that? Yes. Say that on the second step, how did the G, Y is? Because remember this area, if we just did the integral, because this area is below the x-axis, this integral would be a negative. But we're just finding the area. We're not finding signed area where we care about the positive and negatives. We just want area. So we want the area to be positive. So we're going to negate this negative integral and make it positive. It's weird. It's going to get weirder when both curves are below. So we definitely want to make sure you guys are okay with that. Any questions about that? All right. Then let's see. Let's see what happens when both of them are below the x-axis. So both curves below the x-axis. So again, I'll draw a picture so we got something to fall back on. Whoop. I'm still going to put f on top though. So y equals f of x will be above, whoops, g of x. And we're still going to put our lines. X equals a and x equals b. And this time we're looking at this area. So this time, that pink area is going to be the area between the x-axis and g of x, but then we're going to take away this white area here between the x-axis and f. So we're going to do the area, well, I'll just write it out. So the area is the area between x, I can't spell axis. There we go. X-axis and g of x minus the area between the x-axis and f of x. So any questions on that? Got to make sure we get that first before we translate it into math. Okay, so let's see what happens here. So keeping in mind when we need negatives, anybody want to try translating this into math? Yeah, Trick? Good. You want to keep going? Minus, and what's the area between x-axis and f? Excellent. So I'll let you look at that for a second. Is this a question on this, Yoj, or a comment? Okay, hold on one sec. Any questions on this? Yoj. Yeah, the minus and negative on the f is just going to make that integral positive integral from a to b. Nice. We still have a minus sign in front of the integral of g. And again, they have the same limits on the integrals, so we can combine it into one integral and say the area is the integral from a to b of f of x minus g of x. And this time, looking at the relation of top and bottom, this time F is the top. Oh, look. Hey. Well, this is awfully convenient, isn't it? It's still top minus bottom. Oh, thank God. We don't have to memorize 3 different things. Just one. Top minus bottom. So the moral of the story, we did all of this so I could convince you that no matter where the curves are in relation to the x-axis, when you are finding the area between 2 curves, it is always top minus bottom. Yes! This is a good thing. Very easy to remember that. Let's kind of summarize this, though. But any questions over any of this that we did? Oh my God, it's exciting. I know I'm going to pee my pants. I'm so excited. That's Grossness showing here. Yeah, it is. All right, area between 2 curves. So, it is either, because we actually do have 2 cases, and I'll explain the 2 cases when we do examples. But, Godzilla, it is either going to be, and I'm just going to really make this kind of loosey-goose. It's either going to be top minus bottom, or that's if it's a dx problem. But if it's a dy problem, and I know that may not make any sense right now, but when we do the examples, hopefully it will. If it's a dy problem, we could go through the whole thing again. I'm not going to make us go through all 3 scenarios, but it turns out it's always going to be the same thing. In this case, you think right minus left curve, if it's a dy problem. And I know there's probably questions on that, but I don't care right now. How many times have you ever had a math teacher who says, I don't care if you have questions, damn it. If you have questions at the end of this lesson, then I care. So let's just do examples now. We're going to have 4 examples. One of the examples has 2 parts to it, so you can think of it as 5 if you want. The last example is going to use a calculator. And I'm going to show you some cool stuff on the calculator that you may or may not know yet. Stuff I haven't shown you yet this year, though. Anybody still need this before we look at our first example? So here's the first example. I'll let you guys write that down first. Find the area between those 2 curves. These problems do get kind of long and involved, especially depending on your graphing capabilities. And even though we have a graphing calculator, you will not be able to graph everything on the calculator. This is not a calculator problem. And honestly, if you have trouble graphing, this is just a line and a quadratic. If you have trouble graphing these, please don't hesitate. Come into study hall and get help, or let's set up a time after school. Even things that aren't just a line or a parabola, like some basic cubics, square roots. Like if you have trouble with all the graphing that's going to show up on your homework, come in for help. Because it's actually going to cut, like all of the rest of the unit is going to involve a lot of graphing. Yay! All right, now that I made you so excited, let's take a look. Step 1 is always going to be to draw a picture. And I don't care if you can visualize the picture in your head. I want you to draw a picture. I will be looking for the picture on the test. Draw a picture. If you don't draw a picture and you do everything else right, I am not going to give you full credit. Draw a picture. Step 1. Draw a picture. Now, here are the minimum things that I'm going to want on your picture. Because your picture doesn't have to be drawn super precisely or, you know, like to scale. These are the minimum things I'm going to want to see. We're going to be talking about curves intersecting. So, bare minimum, you need to include points of intersection. As we can see from the formulas we wrote above, top minus bottom, right minus left, your picture should accurately show which curve is on top and which one's on bottom. So it should show the position of the curves in relation to each other. So top versus bottom, right versus left. And then the other thing that I'm going to put on here are X and Y intercepts. And you'll get the feel for this. I'm actually going to put here when necessary. Godzilla. It won't make much sense right now. What I mean by the when necessary, when it's necessary to set up your integrals. Hopefully, again, by the end of all these examples. So, your curve, like let's say you're not exactly sure what the shape of the curve is. Maybe you don't know, it's not just a parabola or a line. So you don't know what the curve is. But one curve's above the other curve and you can find the points of intersection. I'm fine with something like this, literally. It just has to show so you can set up your integral. All right, so this guy, though, we know it's a parabola that smiles and a line with a positive slope, so we can get a general idea. But we do have to find the points of intersection. How do you find points of intersection between two curves, Trey? Exactly. So let's do that. So first we're going to find the points of intersection. So we'll set x squared plus 2x plus 1 equal to 2x plus 5. And then you just solve. We can subtract the 2x from both sides of this equation. Subtract 1. So I think I heard somebody say x equals 2. Ah, yeah, don't forget the plus or minus. We got 2 points of intersection. So, the points, when x is 2, and then you can just plug, do this in your head. You can plug into either one. You should get the same value for y. Definitely be easier to plug into the line. So when x is 2, what does y equal? What's 2 times 2 plus 5? I know, it's a tough one. 9, yes. And when x is negative 2, what? Do we have our points? Any questions about that? All right, we may need to find the intercepts. I don't know. Let's draw this thing and see what happens. See if we need to go in and find the intercepts. Sometimes the intercepts are super easy to find and sometimes they're not. Sometimes they're not easy, but you still need them. So I'm going to wait. Let's just wait. I just lost my train of thought. Oh, no, I didn't. Okay, so I'm going to draw a picture. So literally, this is what I'm looking for. I'm going to put those 2 points I'm not going to put them super precisely. I'm just going to kind of eyeball the relationship between those 2 points, like 2, 9, that'd be somewhere up here. Negative 2, or sorry, yeah, negative 2, 1 would be somewhere down here. Should be below the 2, 9. So I am asking you to make these graphs, but I'm not asking you to go through a whole lot of effort. Now I need to draw a parabola that smiles, and so we're going to be crossing the x and the y axis to do this. As you get the hang of it, you'll be able to think about this in your head, whether or not you need the intercepts. I'm just going to go ahead and put it here. We'll look at it. Maybe I'll have to redraw my picture a little more accurately to get the y-intercepts and the x-intercepts if I need it. But I know the parabola that smiles, it goes through those 2 points. Something like this. I don't know exactly how low it goes. I'm not even thinking about that. I don't care. Let's see. I called the parabola f of x, so I'm just going to label this y equals f of x. And then I need to draw a line that goes through those 2 points. And this is y equals g of x. So it looks like this is the area between the 2 curves. So, any questions getting this picture? And now I'll be able to show it a little better on another one. Actually, no, I take it back. This is a good one to show it on. Because I gave you top minus bottom, or it could be a right minus left problem. So what do I mean by that? Well, imagine putting a rectangle. Let's start with a rectangle that goes vertically. And really what this rectangle is, we sometimes call it the representative rectangle. Remember way back when we did Riemann sums? If it brings back memories. But remember when we did that and how we started off by drawing rectangles to represent the area? This would be one of those rectangles. So the question is, if the rectangle is going vertically, but imagine we had rectangles going all throughout this area, as the rectangle moves across the area, is it always the same curve on top and the same curve on the bottom? Does it ever change? What do you think? Is it always the same or not? Thumbs up if it is, thumbs up if it's not. Yeah, I'm not seeing too many thumbs, but everybody's thumb that's up is up. Yeah, it's always the same. No matter where I put that rectangle, I could put the rectangle here, 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 here. I'm going to erase all these. Don't write it down. But no matter where the top of the rectangle hits the blue curve, the bottom of the rectangle hits the green curve. So, yeah, it's always the same thing on the top, always the same thing on the bottom. That's a good sign. Top minus bottom is a way to do it. Imagine if we went horizontally. If I went horizontally, is it always the same curve on the right and always the same curve on the left? Horizontally. Thumbs up if you think it is. Thumbs down if you think it isn't. Can you see it? I'm seeing more thumbs this time. Still not too many. But everybody's thumb is down. Yeah, it's not the same. Up until this dotted line. Above this dotted line, it's the green minus the blue. Green is on the right. Blue is on the left. But as soon as you cross this dotted line, green is still on the right, but it's also on the left. So it did change. We'd have to make two different integrals then. And I'll show you, there's an example coming up that's going to be like that. Let's see if we can do this as a dx problem. Top minus bottom. So I'm going to leave my picture like this with that green rectangle. So I've got my picture. And if we just think about it, because remember we still have to figure out, do we need the intercepts? Because step 2 is just going to be now to set up the integral. What do you guys think? Anybody have an idea how to set up, like, do you think we're going to need the x and the y intercepts to set up the integral? Yeah. The left point and the right point of this area We already know. We don't need to find the intercepts. We're good. Sweet. Let's move on. So, step 1, draw your picture. Step 1, there's a lot of like background thought going on. Step 2, line these up. Step 2, set up the integral and solve. So, anybody know what integral we're going to work out to figure this out? What's the top curve? Let's start with that. Which curve is on the top? Blue or green? I think I heard it. Say it again. Blue, yeah. It's the line that's on the top. So the top curve is 2x plus 5. And the bottom curve is x squared plus 2x plus 1. What are my limits of integration going to be? Andrew, was that a hand up? Perfect. Negative 2 to 2. And that's the integral we're going to solve. So, top minus bottom. And since it's a dx problem, we use the x coordinates of the points. Any questions on the integral? Because now I want you guys to solve it. Go ahead and work it out. Ooh, wrong way. Godzilla. There, I can see everything. Get used to fractions. I'll tell you, most likely on your test coming up, which, not for a couple weeks, don't worry, I forget exactly when it is. But most likely, your test will be part calculator and part not. Like, I would expect you to be able to work something like this out relatively quickly on a test. The AP exam will expect that too. But then I might give you other integrals where I just want you to set them up, and then you can use your calculator to get the answer, which I'll show you. I'll remind you how to do in a second. I think I've shown you once briefly, but you'll be using your calculator a lot more this unit. Any questions on that? I know, right? Anybody still need this? Because we're going to go on to another example then. Alrighty then. So here is, I didn't need another page. Here is the next example. And go ahead and try setting up the picture. Write it down and try setting up the picture. Picture should look something like this. Any questions about that? All right, so looking at top minus bottom, right minus left. Anybody have any thoughts on this? I'm gonna zoom in just so we can see it. It's so little. So this one we actually have some choices just regarding top minus bottom, right minus left. Either way, because the curves flip, first it's the pink curve on top, then it's the blue curve on top. So we're actually going to have to use two different integrals no matter which way we do it. If we're doing top minus bottom, over here the blue is on top and then the pink, but then it switches to the pink on top and then the blue. If we're looking at right minus left instead, the pink is on the right up here, but then becomes the blue on the right hand side. So we're kind of stuck there. If we have our choice then, these equations are already in terms of x minus 1, x minus 1 cubed. Let's make it a dx problem, and let's do top minus bottom. Anybody notice anything else about this picture though? Marcus? Yeah. We have some nice symmetry on this picture. So maybe we actually don't need two different integrals. This area here will be equal to this area here because of the symmetry. If you happen to know that. If you don't know it, you can make two different integrals. It won't be that big a deal. But you definitely save time by seeing the symmetry. So let's make some notes here. There's symmetry that is making equal areas. So how about we just find one of the areas and then double it? Does that make sense? Any questions about that? Now we can do either one. Personally, I like to avoid negative numbers when possible. So we can go from here to here, or we can go from here to here. I also like zeros when possible. And I think that's what most people like too. Most people like zeros when possible or positive. Sometimes you don't have a choice, you're going to have to do it. But which area do, well, actually no. If we think of this as like the bottom area and the top area, anybody have an idea which area is probably going to be the easiest? Trey? Yeah. We may be thinking the lower one's negative area, but remember, we're not worrying about that anymore because we're just doing top minus bottom no matter what. If we look at the lower area, I'm trying to think how I want to write this. Let's just do this so it's clear what we're doing. So we're going to double the lower area. So let's focus on that. So looking at just the x-coordinates, because we're going to make it a dx problem. The x-coordinate for this point of intersection is 0, and the x-coordinate for this point of intersection is 1. So we can go from 0 to 1. And then in this lower area, the top curve is the cubic, and the bottom curve is the line. So it'll be the cubic minus the line. Dun-dun-dun. So any questions on the setup? We're going to go through this one kind of quick. All right, just to get it started, well, let me ask this, because there's actually two ways to go about this one. Anybody have an idea how to find the antiderivative? What's one strategy we could do? Trey? We could do use substitution. Because you have words just escaped me. You have a composition. We have an x minus 1 inside of cubed. So you totally could do use substitution. Or, what's another way you could do this one? Yoj? Yeah, you could just multiply it all out. Either way is going to work. And honestly, since we already expanded x minus 1 cubed up here, you already had to go through that work, whether you knew the formula or didn't. So it's actually pretty easy to expand it out. It's also pretty easy. This is one of those use substitutions when you get the hang of it, you could do fairly easily in your head. Anyway, either way, I'm just going to expand it out just because it's easiest to explain on this one, and I don't want to get caught up on the use substitution. So if I expand it out, and then combine like terms, we get this, and then that would be easy to integrate. We're actually going to use our calculators at this point, for sake of time. This would be one, though, I expect you could do fairly easily on a test. But any questions just getting to this point? All right, so go ahead and take out your calculator. Let's remind ourselves how to do this. I got my big calculator back. So, all you got to do, anybody remember where you get the definite integral from? After this unit, you're going to know it like the back of your hand. Definite integral, Math 9. Hit the Math key. Sorry my calculator split, but at least this is big so I can show you. So Math key should be on the left-hand side of your calculator. And then if you just type the number 9, it brings up the definite integral. And actually, I'm going to go ahead. I want to double it. Let's just make the calculator do all the work for us. So I'm going to do 2 and then Math 9 from 0 to 1 of x cubed. What was it, minus 3x plus 2? No, minus 3x squared plus 2x. And don't forget to fill in the dx at the end, because your calculator knows you need a dx. And then hit enter, and you get this. And by the way, I mean, I hope we all know that 0.5 is 1/2 as a fraction. But remember, your calculator can change things into fractions as long as it's a rational number. Anybody remember how you do that? Almost everything we do is going to be under math, unless we're in the graph. Hit math again and look at choice number 1. Change to fraction. Your calculator can make it into a fraction for you. So the answer is 1/2. Oops, wrong button. Dun, dun, dun. Any questions there? All right. Anybody still need this? You maybe go, is that all we're doing on the calculator? No, just you wait. Let's look at the third example. And just again, for sake of time, we're not going to do part A. Even though part A on this one would be easier. But I want to see how you do a dy problem with you guys. For fun, you could go back and do this problem and do it as a dx problem, and you should find you get the same answer. So first we're going to draw a picture. And to draw a picture, don't worry about the respect to y thing yet. I know it's a line and a parabola. Let's find our points of intersection like we've been doing. Ugh, messy picture. But your area should look something like this. It's very similar shape to what we had for the first example. So any questions on the picture? All right, now this one is definitely easier as a dx problem. It's very similar to that first problem we had. If you look throughout the entire area, the green curve is always on the top and the pink curve is always on the bottom. So top minus bottom would be consistent. It's already in terms of x, the two equations. So definitely part A, doing this as a dx problem, would be easier, but we're up for a challenge. Let's make it a dy problem. Let's see what that would look like. So, just like we did before on that other picture, we are going to have to consider this area into two pieces. I'm going to split the area right there at that horizontal line at y equals 4. And we're going to look at the bottom area in a different integral. So the pink area, the right minus left, is going to be green minus pink. This icky, whatever color this is now, I guess it looks green, is pink minus pink. So we'll see how we handle that. So let's see how we do this. Godzilla! The first thing that we're going to have to do is we're going to have to rewrite each equation in terms of y. So for g of x, which one was g? For g of x, if we think of that as y equals x squared, solving that for x, it's x equals plus or minus the square root of y. And then for f of x, that started off as y equals 6 minus x. So if I solve this for x, add x onto both sides, and then subtract off the y, it's x equals 6 minus y. So we have both equations written in terms of y. Solved for x in terms of y. So now, the area. So first let's do the pink area. The area is shaded in pink above. So that's the green minus the pink curve, or f minus g when you look at right minus left. So this minus this, except we got something weird here. F, when it's written in terms of y, is just 6 minus y. However, for this guy, I got plus or minus root y? Wait a minute. How do I put a plus or minus into an equation? That's going to give me two different answers then. Only one of them is the correct one. The left-hand side of this parabola, does the left-hand side of the parabola represent the positive square root of y or the negative square root of y? Because it's only one of those. Trey? Say which one? It's the negative. Yeah. And you can actually, this one's easy to see because all the x values are negative on the left-hand side of the parabola. So we want x to be a negative on the left-hand side of the parabola. So the negative root y represents the left part of the parabola. The positive root y represents the right-hand side. So it's actually minus negative root y. And then what about my limits of integration? Anybody have any idea what the limits of integration are going to be? Yoje? It is. Very good. This time we're looking along the y-axis because it's a dy problem. So the area starts down here at y equals 4 and goes all the way up to this point where y equals 9. So that's when my limits are 4 to 9. And that's the pink area. But then we still need to add the green area. Any questions about that? So let's look at the green area. How about just the limits of integration? Again, going on the y-axis, the green area is between what two values on the y-axis? What's the lowest value? 0. And by the way, this would be one of those cases, we need the, I guess this is x and y intercept. We need this point. This one, though, because it's just x squared, we know it's the origin. So that's what I mean by when necessary. But yeah, the lowest value is 0. The highest value for y is 4. So our limits are going to be from 0 to 4. Anybody want to try the integrand? This one's, again, think about what we were saying before. The right part of this green area is the right part of the parabola. The left curve is the left part of the parabola. What was the right part of the parabola again? Which one, positive or negative? It's the positive. So the right curve is the positive square root of y, and then it's minus the left, which is negative root y. And then this wouldn't be so bad to work out. Yes?
Since it's metrical, could you also write 2 times the integral with just 1 short line? It's metrical.
Say the, you're right about the symmetry, so say it all again.
Write 2 times the integral with just short line.
Yes. And if you did that, because of the symmetry, so your right minus left is root y minus 0, which is why it just ends up being root y. Very good. And then we'd work that out. But again, I'll just save time and not work it out. That was pretty easy because it's just power rule all across. But any questions about that? Yes?
Symmetrical, do you have to change the boundaries to 0 to 2?
No, because you're still on the y-axis going from 0 to 4. In fact, if you think about it, when you simplify this part, minus a negative makes it plus, so you're going to have root y plus root y. You're still going to get 2 root y. So you still get the same thing. Any other questions? Okay, are you ready for the grand finale? I see heads shaking no. Let's do it anyway. All right, we're going to use a calculator for this guy. So go ahead and write it down, and then we'll take a look here. Actually, I'm just going to make note of these curves here so I know them. All right, so step 1 is going to be to draw a picture, but it does say use a calculator, so we're going to let the calculator draw our picture for us. Anybody still need the problem? Okay, so I'm going to go into my calculator. I'm going to go to y equals, and I'm just going to enter in those two curves. So 3x cubed minus x squared minus 10x for the first one, x squared plus 2x for the second one. And then you guys might, remember how you can change the window on the calculator? If you hit graph, you may or may not be able to see stuff. Did I type it in wrong? Oh, I did. Thanks. Oh, actually, this will be a good opportunity to remind you about insert. Because you know when I start typing, how it's just going to start overwriting? There's not much to type, so it wouldn't be that big a deal. But remember, insert, right above the delete key is insert. So if I do second insert, I can put my minus sign in. It just moves everything over. I just always like to start with zoom 6. And there's my curves. Kind of Vicky looking, but that's it. So I'm going to put this on the notes real quick. Even though if this was a test, and even though I'm letting you use a calculator on this problem, I still want the picture. So just put a little sketch. Let's see, it looks like the cubic does something like this. I can definitely tell it's going through the origin there. And then I got a parabola. Can't really tell if they're intersecting at the x-axis itself on my calculator. Doesn't quite look like it. So pink is g, y equals g of x. The purple is y equals f of x. How many of you guys have seen how to find points of intersection on the calculator before? Okay, I'm going to show you how to do it. So, in this case, there's 3 points of intersection. But even if there's only 1 point of intersection, your calculator still wants you to tell it roughly where the point of intersection is. So basically, what you do is, I'll show you how to do it, but the calculator is going to ask us 3 questions. What's the first curve that we want to find the point of intersection? What's the second curve? And roughly, where do you think the point of intersection is? So the way you do that is above the trace button, you'll see calc. So hit second calc, and that will open up this menu here. And you can see that the calculator can find a lot of stuff. It can actually find a value. You give it an x value, it will find the corresponding y value. It can find zeros or x-intercepts. It can find a minimum, a local min or a local max. But we want choice 5. We want the intersection. So I'm going to just hit 5. Now, at first glance, it doesn't look like it did anything, but it's actually asking me some stuff. So it's asking me the first curve. And I can see on the top that it's choosing y1. If I just use the up and down arrows, it'll cycle between y1 and y2. So in case you have like 3 or 4 curves on your graph, that's how you can choose a specific curve. But y1 is good. I'm going to leave it there. But I'm going to confirm this by saying enter. So hit the enter button. And now it's asking me, what's the second curve? And you can see that automatically switched to y2 on the top, which is good. So I'm going to hit enter again. And then it wants a guess. And so this is where you move your cursor around and get it close to one of the points of intersection. So let's just go for the very left one. That's close-ish. I hit enter, and there's my point of intersection. Anybody need help with that? So I'm going to go ahead and make note of these. Problems like this where they've got these messy decimals, just go ahead and give me 3 digits. So this point right there is negative 1.6. I already lost it. 694. Negative 0.518. This point's at the origin 0, 0. See if you can find that right point of intersection on your calculator. The second, oh, you mean the, oh, the 0, 0?
No, I mean like the second.
Oh, the number? Wait, you mean this?
1.69.
Oh, yeah, I'll go through that. I'll do it with the right one, though. I'm going to find, oh my god, that point of intersection over there. By the way, I do have a little problem here, potential problem. That right point of intersection might be off the screen. And it does need to be on the screen for your calculator to do it. So I'm just going to zoom out a little bit. I'm going to go to zoom. I'm going to choose zoom out, choice 3. And remember, your calculator doesn't actually zoom out yet. It wants to know where you want the center of the zoom out to be. So I'm just moving my cursor back to the origin. And then I'll hit enter. And it zooms out. Oh, that's really ugly. Here's another trick you can do too. Doesn't always work, but under zoom, there's a zoom fit. Choice 0 is zoom fit. Your calculator tries to guess what the important points are. Yeah. Like I said, doesn't always work. Sometimes it does. So I'm going to go back here and just go up higher on the y-axis. So I'm going to change my window and change my y max to, I don't know, let's go to 40. Let's see what that looks like. There we go. I can definitely see the point of intersection now. Alright. So now I'm going to go through the steps for the point of intersection again. Second calc, choice 5. First curve, second curve. And move my cursor over there. So you should have gotten about like that. 2.360. 10,295. Get it?
I'll have to just click enter twice.
You know, so look at the right on top, and now it'll hit enter.
Maybe that's just
Hit second curve, let's start over. And then do second calc. So, see, it's asking first curve, which is what I want. There we go. And then guess, now you're close to the intersection, so hit enter one more. Anybody else need help? All right. So now we just have to set up our integrals. Yay! Now, this is, what do you guys think? DX or a DY problem on this one? Yeah, definitely DX. Couple of reasons why definitely a DX. First of all, I mean, yeah, we do have, oh, my picture's not very good, is it? I can't believe I did this. You guys are probably going, what the heck are you doing there showing here? That is not the point of intersection down there. Can I salvage this picture anyway? I need to make the pink curve intersect. Alright, let's try this again. Was it 2 point? I lost it. 360. 10.295. Right? Remember, I didn't say that the shape of the curve was as important. We still have the pink on the top, and that's what matters. By the way, one thing I do want to point out, getting us ready for the AP exam, this guy right here, some of you guys may be going, oh man, that rounds up though. The 9 makes that round up to 0.361, and you're right. On the AP exam, you can do it either way. You can do truncating, which is what I was doing, or rounding. Truncating is where you just cut it off, and 360. Or you can follow the rounding rules and make that round up. However, be careful, because if this was like, instead of a 9, let's say it was a 4, the 4 would not make this round up to a 1. It would leave it as a 0. And if you put 0.361 when it wasn't supposed to round up, that doesn't count, and you lose the point. So that's why I just get in the habit of truncating. That way, it's always going to work. I don't have to worry about, wait, is it round, is it not, making a silly, stupid mistake. So my recommendation is just truncate, but you can do it either way. All right, so we got this. So let's set up our integral. So the top minus bottom, now that I have a good picture, we can still see that we're going to need two different integrals. If I was trying to do right minus left, though, I'd have right minus, like I'd have a couple of problems here. First of all, with this first area right here, I got the purple minus the purple. The other question is, how do I even solve this equation? Look at f of x. How do I even solve that for x? Exactly. So this is definitely going to be a dx problem. It's already in terms of x. Top minus bottom's very clear. Let's go ahead and just leave it that way. But we still need two different integrals. So the area for the first integral, for this first area, it's going to be a dx problem, so we'll look at the x coordinates. Negative 1.694 to 0. Negative 1.694 to 0. And I'm going to make it easy. The top curve is purple, which is f of x. The bottom curve is pink, which is g of x. We've already defined in the problem what f and g are, so I am just going to write f of x minus g of x. That is allowed, as long as in the problem somewhere, either the problem itself defined what f and g are, or you defined it, if you wrote it down somewhere. But as long as f and g are defined, you can do that. That's proper math notation, so you can totally do that. And then we're going to add to that the next area, which goes from 0 to 2.360. But this time the curves switch positions. This time g of x is on top. So g of x minus f of x. You can do this on the AP exam. You can do it on my tests. Because like I said, it's proper math notation. Totally fine. But make sure the curves are defined. A lot of students will do this, but they haven't defined what the curves are. And then we'll put this on the calculator. A little tedious, but, and I'm going to show you this. This will be the last thing we do. Any questions just in the setup of the integrals, though, before I go to the calculator? So remember, we've already got these things typed in. F of x was already typed into y1. Well, I don't know where you typed it. I put f of x into y1, and I put g of x into y2. So I'm going to make use of that. So I'm going to do second quit, first of all, to go back to that home screen. And let's just clear everything out. Start from scratch. So I'm going to do math 9. And I'm going to go negative 1.690, wait, 694, negative 1,694 to 0. And f of x minus g of x on my calculator is going to be y1 minus y2. Anybody remember where you get y1 and y2 from? Joshua? Yeah. Remember vars. Next to the clear button. So you go to vars. It's a y variable, so scroll over to y variable. Their functions. So y1 minus y2. And then I can either find this value, or I can just go ahead and keep going. Add math 9. And do the other integral. 2.360. 2.36. But this time, y2 minus y1. $26,716. And there you go. So when you get the use of using your calculator for all of this stuff, it actually becomes pretty quick to set up. Any questions about that? So for tonight's homework, I'm going to let you do it either way. I want to at least see that you've set up the integrals. Now, honestly, I'm going to think about where you are in finding antiderivatives. If you're like, I'm not exactly sure if I can do definite integrals, I think I need a little more practice, do the definite integrals by hand, especially when they look pretty simple. But if you want to practice using the calculator, which I definitely encourage you to do, as long as you set up the integral on your paper, then you can use the calculator to evaluate it for you if you want. But remember the test, my test and the AP exam, you're going to have to do definite integrals by hand, so make sure that you know how to do it. Any questions? Yes.